Hello everyone. Welcome in an online lecture series for engineering mechanics. I am Professor Radhika Kapate from Civil Engineering Department and Vishwabharati Academy's College of Engineering. Okay, so as we seen in a previous lecture, the basic concepts for the engineering mechanics. So what we seen, that is engineering mechanics, what are the types of engineering mechanics, what is mean by static, dynamics, kinetics, kinematics. Okay, so also we seen there in a like units, four fundamental quantities of units, then their symbols, physical quantities, and some unit conversion, then basic concepts like push, pull with the example. Then we also seen the necessity of forces, effects of force, characteristic of force. And now we are here continue, that is line of action of force. So what is mean by line of action force? That it is a geometric representation of how the force is applied. So you can see here in a diagram, it is the line through the point at which the force is applied in the same direction as the vector F, that is force. Now here you can see forces, that is gravitational, unbalanced, balance, mass and weight. Okay, so what is mean by force? That is force is a physical quantity that changes or tend to change the state of rest or the uniform motion of an object. And force is a vector quantity as it has a both magnitude and direction. Okay, so next, that is system of forces. Here are some systems, like when two or more forces are act on a body, they are called system of forces. So number one is a coplanar force system, that is 2D, and non-coplanar system, that is 3D. Okay, so second is concurrent and non-concurrent force system. Third is a collinear and non-collinear force system. And last one is the parallel, like and unlike. Okay. So here you can see this diagram, that is the system of forces, that is coplanar. So first one is the coplanar. What is mean by coplanar? It consists of forces which have lines of action in the same plane. And non-coplanar, that is what is mean by non-coplanar? That is space forces, means it consists of forces whose line of action do not lie in one plane. Okay, so coplanar is divided in collinear, concurrent, non-concurrent force systems, and no non-coplanar is divided in again concurrent and non-concurrent force system. So what is mean in a collinear? That is like or unlike. And what is mean by non-concurrent is parallel and non-parallel force system. Okay, so here go for the non-coplanar force system. That is non-coplanar is a parallel and non-parallel. Okay, then next one is the coplanar force system, that is 2D. So in a coplanar, you can see that is 2D system, the on a same plane but different line of actions. That is the forces F1, F2, F3 in the first diagram. And in third, that is coplanar concurrent force systems. As we know, coplanar is the same plane, and concurrent means forces whose lines of action intersect at a single point. Okay, and third, that is coplanar parallel forces, means same plane but parallel forces which have parallel lines of action. And the coplanar non-concurrent or non-parallel forces means the same plane but that forces are not parallel or not intersects from a same point. Okay, now non-coplanar force system, that is 3D. So first one is no non-coplanar concurrent system forces. Second is non-coplanar non-concurrent system of forces. And third is non-coplanar parallel system of forces in 3D. You can see here. Here, concurrent and non-concurrent force system. As we see, the concurrent, it consists of forces whose lines of action intersect at a single point, and concurrent force system can be coplanar or non-coplanar. And non-concurrent forces, you can see in the diagram. That is, what is non-concurrent force system is consist of forces whose lines of action do not intersect at a single point. Okay. Now, collinear and non-collinear force system. What is meant by collinear? You can see here in a first diagram, it consists of forces which act along the same straight line. Okay. And non-collinear forces are which the forces which do not act along the same line, that is different lines. Okay. In second diagram, parallel force system, as it is a simple, it consists of forces which have parallel line of action. If all forces act in the same direction, the forces system is called like parallel force system. And if the forces do not act in a same direction, it is called unlike parallel forces. That is in a second diagram. Now, models or idealization in mechanics are used in order to simplify application of theory of mechanics. Okay, so here we will consider three important idealization, that is rigid body, particle, and concentrated forces. Now, here you can see, to simplify application of theory, the particle, a body with mass but with dimension that can be neglected. So size of Earth is insignificant compared to the size of its orbit. So Earth can be modeled as a particle when studying its orbital motion. Okay. So in mechanics, rigid body means what? It is a combination of large number of particles in which all particles remain at a fixed distance. That is practically from one another before and after applying a load. So material properties of a rigid body are not required to be considered when analyzing the forces acting on body. In most cases, actual deformations occurring in structures, machines, mechanisms, etc. are relatively small, and rigid body assumption is suitable for analysis. Now, concentrated forces. So, effect of a loading which is assumed to act at a point, that is center of gravity on a body, provided the area over which the load is applied is very small compared to the overall size of the body. For example, contact force between a wheel and a ground. Here you can see. So next is the fundamental concepts. So there are some fundamental concepts, that is length. So you know what is length. It is needed to locate position of point in a space or describe size of the physical system, that is distance, geometric properties. Time, you know, this is a measure of succession of event, that is basic quantity in dynamics. Mass is the quantity of matter in a body and measure of inertia of a body. It resistance to change in velocity. And force represent the action of one body on another, that is characterized by its magnitude, direction, and action. So from its point of application. So force is, as we know, vector quantity. Now, Newtonian mechanics. So length, time, mass are absolute concept independent of each other. So force is derived concept not independent of other fundamental concept. So force acting on a body is related to the mass of body and the variation of its velocity with time. So force can also occur between bodies that are physically separated, that is gravitational, electrical, and magnetic forces, etc. So remember, mass is a property of matter that does not change from one location to another. And weight refers to the gravitational attraction of Earth on a body or quantity of mass. Its magnitude depends upon the elevation at which the mass is located. Weight of body is the gravitational force acting on it. Next is the scalar and vector quantities. So basics for the comparisons are meaning, quantities, change, operations, comparison of two quantities, and divisions. What is scalar and vector quantity? So the meaning of scalar and vector quantity झाला बंद केला झाला ना तो रेकॉर्ड झाला की नाही मला चेक तर करू दे. झालं ना
इकडे नाही होत रेकॉर्ड झालं. आता मिनिमाइज करू का सगळं?
क्लोज बंद करा. क्लोज करा ना. करता येईल त्याला. रेकॉर्डिंग चालू नव्हतं का?
इन मीटिंग